Okay, so we're going to work on optimizing perimeter and area. So very similar to what we've done before, but in this question, they've given us a constraint with the area, and we need to essentially find the perimeter. We need to enclose 40 meters square. Okay? We want to minimize the amount of fencing. What did we learn from the last one, especially if we're going to use a four-sided shape, let's say?
Circle.
Four-sided shape.
Oh, never mind, square.
That's okay. He was right. A circle would have been better. A square would be best. If it's a four-sided shape, a square would be best. And because perimeter of a square is equal to 4L, okay, and we have our area being 40, okay, we need shapes. We need shapes here. In this case, our area needs to be length times width, but for a square, the length and the width are the same. So area is equal to L squared. We know area is 40, so 40 is equal to L squared. So in order to figure out L, we need to square root our 40 here. Okay? So the square root of 40 is 6.3. So according to this, a length of 6.3 all the way around will give us the most efficient shape. Now, let's say we're building a four-sided shape, but we only need three sides. This is going to be a little different for us. So what I mean by that is imagine we're maybe building on the side of a school or something, and we need to build our fencing around this. Okay, we're going to build our fencing around it. So in other words, I don't need to include a side here. This is very common when enclosing areas that we build a fence attached to maybe a building or something. So if we're making like a playpen or something like that, we need to figure out what ratio of our length to width. Okay, we'll call this the length, and these two will be our widths. What ratio will be best? Let's test our ratio of all the sides being the same. Okay, and then we'll try to go from there. So what I mean by that is, here's our wall. And in this case, we only have three sides. We only have three sides, so we'll go 2 by 2 by 2. And we need to enclose 40 meters in this case, okay? So we only have three sides in this case. So we need to figure out exactly how we're going to do this. If all three sides are going to be the same, we need to split 40 into what? Oh, sorry, that's not the enclosure. That's the area here. Is our meter squared. So this is going to be a length times a length again. Okay? And if we do it this way, our length by our length, we need to add all three together to figure out our perimeter. So we had our 6.3 before is what we had found. So to recap what we've just done here, since our area is 40, we know area is equal to 40. And if our sides are going to be the same, we know our area is going to be equal to L squared, L times L. 40 will equal L squared. Square root 40, L is 6.3. 6.3 gives us an area of 40 meters. Let's move away from this idea instead of keeping the same distances on sides. So we still got to enclose 40 meters. What other numbers or what other, and we'll use whole numbers, are factors of 40? Technically 6.3 is a factor of 40, but let's stick with very whole numbers in this case. 2 and 20. Great. So let's call the width 2 and the length 20. Okay? And we'll figure out if this is better in terms of our minimizing our perimeter. So we know 2 times 20 will give us 40. The perimeter in this case is technically 6.3 plus 6.3 plus 6.3. So that's 6.3 times 3. The perimeter is 18.9. Pretty good. In this case, our perimeter is what? 2 plus 20 plus 2 again. So 22. Which was more efficient with the fencing? The first one, the 6.3, okay. But we can... What's that? Oh, sorry, you're right. It is 24. Thank you. Still, the side lengths being the same was a little more efficient. But let's go with something else. What other numbers multiply to 40? 4 and 10. Okay, so let's try 4 and 10. So same idea. We're going to be building our fence around here, but this time we're going to have, that's not quite straight. We're going to have 4 by 10. We know multiplied together that'll be 40, which means this is 4. So 4 by 10 is 40. That works. And what is our perimeter? Our perimeter will be 4 plus 10 plus 4. What does that add up to? 18. Now, this is very important. What just happened here? Which was less? This one here. Now, did this one have the same side lengths? No. So, what I want you guys to realize from this is when we're only enclosing 3 sides, equal sides is no longer most efficient. There's actually a very specific ratio. And we're going to get to it. Did you notice 4 by 10 used less fencing and still enclosed 40 meters? Okay, this one used a little more fencing. So if I had to pay money for fencing and I made all the sides the same, it would have cost me more in this case, right? Because this only enclosed 40. This one also enclosed 40, but would have been cheaper. I used less fencing. So there's actually a very specific ratio. And the ratio is a 2-to-1 ratio. Okay? 2-to-1 ratio. In other words, the width, okay, should be half of what the length is. Our 2-to-1 ratio. So we should be multiplying our width by 2 to be equal to our length. It's a 2-to-1 ratio in this case. So we want to try to figure out what would be a 2-to-1 ratio, and I wonder if the number 40 is a tough one to use for this. But we need numbers that when we multiply the width by 2, that will give us the length. Okay? Now, in this case, there isn't really a straightforward way of going about it when we have 40. We're going to have to kind of try a little more trial and error in this case. What would 5, or let's find some factors of 40 to get as close as possible to this ratio. We know factors of 40. We know 1 in 40, that would be far too large. We already tried 2 in 20. We found out that 4 in 10 was good, but it's not exactly a 2-to-1 ratio, right? If I multiply 4 by 2, what do I get? 8. So it's not quite a 2-to-1 ratio. What's another number we could use? 5 and 8. Is that a 2-to-1 ratio? No. So it's definitely going to be somewhere in between there. And because we're being very simple today, we know that this will be 10. Okay? Because we're being very simple today, we know that we're going to be in between. Let's create our 5 to 8 and figure out what its perimeter will be in this case. 5 by 8. We know 5 times 8 is 40, so that fulfills our area. And our perimeter, we'd have to add them together. What is 5 plus 8 plus 5? 18. Was that exactly the same as before? Yeah, it was 18. So we know now, whoops, that the best scenario, oh, it's a long page here. Our best scenario is going to be in between here. Somewhere between 4 and 5. Let's try 4.5. Okay, so this will be a little harder here. We're going to try the number in between, 4.5. We got to figure out 4.5 times some length will equal 40. Okay? So we're going to have to divide 40 by 4.5. Our length will be 40 divided by 4.5. Is that what it is? 8.88? Great. So hopefully this is a little better. And it is, actually, because 4.5 times 2 is 9. So that's much closer to our 2-to-1 ratio. So we have 4.5 and 8.88. Okay? We know when we multiply those two, 0.88, we get our 40. So that fulfills our requirement. Let's find our perimeter. 4.5 plus 8.88 plus 4.5, and it's actually going to be 17.88. Not a huge difference, but it is a little smaller than our 18. So the closer we get, and this is the most important part here, when we're enclosing 3 sides, the closer we get to a 2-to-1 ratio, the better. Okay, the less fencing we use while enclosing the exact same amount of area.